Welcome to the iTrust2 demo for the new food diary feature created by Team 1 from Lab 205. Let me start by introducing our team. My name is Alex and my role is front-end data entry. My teammates were Noah, who worked on front-end display, Shizheng, who worked on the back end, and John, who worked on testing. Healthcare providers want to help patients with their diet, but they don't have a tool to track what they eat. To solve this problem, our team has added a patient food diary to iTrust2. The food diary gives patients an easy way to track their dietary habits. The food diary update includes a convenient user interface for adding new diary entries and daily macronutrient totals. This way, they figure out which nutrients they're eating in excess of or which nutrients they are deficient on. The food diary also allows healthcare providers to monitor patients' eating. Each healthcare provider has access to a patient directory of food diaries. Now, the healthcare provider can search and view the food diary of any patient. Our team has designed and implemented the patient food diary. Now patients can record what they've eaten and view their daily macronutrient totals, and healthcare providers can monitor their patient's progress. All patient users have access to the food diary feature. After logging in, the patient selects the My Food Diary option in the patient drop-down menu. From this page, the patient can view their existing diary entries and record new ones. For this example, we previously entered entries to show that they were correctly retrieved by the HTTP request to the REST API. Entries are displayed in order by date with the most recent entries at the top of the table. Entries are grouped by date, with a row displaying macronutrient totals for a given date under all the entries for that date. The bottom of the page contains input forms for creating a diary entry. Front-end date validation is handled by the Angular date input form, with the latest selectable date being the current date. The patient then selects the meal type, enters the name of the food, and enters macronutrient data. The front-end input validation is also handled by Angular numerical input forms. The user then submits the diary entry and can view it in their table. The entry is grouped with the other entries of the same date, and its macronutrient data is added to the totals for that date. If the patient navigates back to the landing page, the activity logs reflect that the user viewed and added diary entries. Healthcare providers, or for short, HCP users, can only view patient food diaries. The HCP selects the patient drop-down menu from the navigation bar and selects Food Diary Directory. From this page, the HCP can search for any patient in the system and view their diary directory, just as a patient would see it themselves. If a user hasn't recorded any meals in their food diary, the HCP sees the message, "No entries found for patient." If the entry they search for has logged meals in their food diary, the HCP is shown the exact same table the patient sees, complete with date, sorting, and macronutrient calculations. If the HCP returns to their landing page, they will also see that their activity has been logged, that they have viewed a particular user's food diary. Our implementation involved modifying 3 backend Java classes and creating 4 new ones. The diary entry class represents a food diary entry. It is the main persistent class in our design and is serialized as rows in the MySQL database. The meal enum simply gives us a way to enumerate the 4 different meal types on the back end and to avoid additional input validation. Diary entry forms are created by the Spring Framework from the JSON input form data sent from the front end. They act as a mediator between the front end and REST API endpoints. This class also does additional input validation checking, ensuring that fields aren't null, etc. The API food diary controller is responsible for handling incoming post and GET requests. It will either return a list of diary entries for a user or add a new entry to the database. To connect our new feature to the existing application, we've added several methods to the patient controller and HCP controller. These methods allow patients and HCPs to navigate to the new web pages. We've also added 3 new transaction types so food diary traffic is logged. iTrust2 now logs when patients view their food diary, when patients create a new diary entry, or when an HCP user views a patient's food diary. Awesome. Now that we understand the implementation, let's look at some use cases. A patient fills out the food diary form and clicks Submit. The front end sends a post HTTP request to the back end. Spring selects the method in API food diary controller that contains the matching annotation for food diary post request. Then, it sees the request body annotation on the diary entry form parameter. Spring then creates a diary entry form from the JSON request body. The diary entry form is used to create a persistent diary entry, which is then saved to our database. This activity is logged by the endpoint as 1901 diary entry created by patient. Immediately after submitting a diary entry, the user's diary entry table is refreshed. This starts by the front end sending in GET HTTP requests to the diary entries API endpoint. This endpoint checks the currently logged in user and returns a list of diary entries associated with that user. This is logged as a 1902 diary entries viewed. Later, a healthcare provider wants to view the patient's food diary entries. They type in a patient name and click submit. The front end sends a GET HTTP request with the patient's username included as a path variable. The API food diary controller returns a list of diary entries for the given username as JSON data. This is logged as a 1903 diary entries viewed by HCP. Thanks for watching. You now understand how our food diary works. We welcome any questions, design concerns, or complaints. My name is Alex, and I worked on audio recording and video editing. Noah, Shizang, and Jonathan worked on the script writing and creating the slides for all the visuals that we've seen throughout this video. Noah also helped with some of the screen capturing.